Great. Well, why don't we get started? So thanks everybody for joining us for this panel on, I think the title is on data discovery, but my guess, my expectation and my hope is that it's going to be broader than that. And so we're joined today by three great panelists who are really in the thick of all that's going on in the exciting world of data management and data management platforms. And so I guess I'll just first introduce myself. So I'm Mike Franklin. I'm chair of computer science here at U Chicago. And I also help run the Data Science Institute here. And just in terms of full disclosure, I should mention that I was involved with the creation of Apache Spark and the creation of Databricks, and I'm still an advisor and a friend of the company, but I've promised that I'll be completely even-handed and maybe even work. I might actually bend over backwards, and that's going to work against Shant, but sorry about that. Really excited to have Sarah Catanzaro from Amplify Partners, Kent Graziano from Snowflake, and Shant Hovsepian from Databricks. And so what I'd like to do is just start off. I wanted to give each of the panelists a chance to introduce themselves and say a little bit about what they do and kind of what they're excited about in the data ecosystem these days. So I'm going to start off with Sarah. So Sarah, please go ahead.
Cool. So I'm Sarah Catanzaro. I'm a partner at Amplify Partners. So we're actually an early stage venture capital firm, but we really invest primarily across, I'd say, like three technical disciplines. So data management, machine intelligence, and distributed systems. But if I'm mapping that more to kind of the industry space, it would be data and ML tools and platforms, enterprise infrastructure, and then developer tools. So, I think it's really interesting to kind of think about the panel constitution, because in many ways, I think it kind of represents like what we are seeing in the data space nowadays. What I've observed is that like really there are two stacks that are emerging, and one kind of hinges on the data lake and data science and ML. And the other really kind of hinges on the data warehouse and analytics. And what I'd say just kind of in general is that like it feels like the data analytics stack is really maturing and the data science stack is really emerging. So what I think we've noticed across our portfolio and just in observing various market trends is that in the past like 5 to 10 years that the data warehouse has kind of like emerged as the cornerstone of the analytics stack. But in addition, you've seen kind of this whole new set of tools, whether it's like reverse ELT or data modeling or BI. Some of these tools are designed for kind of self-service so that people who don't have like very specialized technical expertise can do things like build tables or create dashboards or add new metrics and events. And I think that's been very empowering to a lot of organizations, but it's also creating this whole new set of problems because like when a lot of people can create tables and events and metrics and dashboards, they do. And so you just end up with kind of like a data swamp that exists in the data warehouse. There's a lot of stuff. It may be inconsistent. It may not be high quality. It may not be properly governed. And so, as an investor, we're investing in a lot of companies that are trying to kind of like dredge the swamp, if you will, that are trying to answer questions like, how do I access data? How do I govern data? How do I trust data? And that seems to be kind of the set of questions that a lot of data practitioners are focused on nowadays. Now, as an investor, like the question that I'm asking is like, what's next? Like once you figured that out, what do you do? On the other hand, as I was mentioning, you've got a data science stack that's kind of emerging around the data lake, but I feel like that's a lot less well defined. People are still trying to understand like what are the core components of my data science and ML stack? Like, do I need a feature store, or is that really the same thing as a data cube or a metrics repository? What is experiment management? How is that different than model version control? So it feels like there's kind of a lot of ambiguity there. But I've probably gone on for over 5 minutes, so I will.
Nope, I've been watching.
Share the stage. Awesome.
I have the foghorn that goes off after 5 minutes. So great. All right, thanks, Sarah. So you raised a lot of the issues we're going to be talking about. So next up, going alphabetically, is Kent Graziano from Snowflake, who's a chief technical evangelist there and has had a long and distinguished career in data management infrastructure. So Kent, if you'd like to introduce yourself and tell us what you're excited about.
Sure. Thanks, Mike. So I've been in the data space for, over, I think, 3 decades now and counting. Spent a lot of time in the Oracle world, OLTP initially, and then moving into analytics and data warehousing, and had a lot of experience working with organizations, either internal to the organization or external as a consultant over the years. And then I joined Snowflake in fall of 2015, shortly after we GA'd, right? Before we IPO'd. And so I've gotten to be on for the ride through the fantastic IPO we had last fall. And it's been really exciting because, one of the reasons I joined Snowflake was because of their ability to merge the relational and what was at that time considered the NoSQL world, to be able to do schema on read and schema on write in one repository, which was something that no one else could. They could do it, but not really well. And so that got me real excited, as the possibilities of having access to more data. I came from a kind of traditional data warehousing background. So the idea of being able to augment the analytics with a lot of external data, like weblogs and IoT data, things like that, I saw as a great possibility for the future, for people to be able to get more out of their data, really get that 80% of the data they couldn't get today. But what I've seen too in Snowflake over the years, you now see my little thing there, the rise of the data cloud. We've gone from being just a data warehouse in the cloud to really being more of a full data platform with data, people doing data lake, what we would consider data lake work, as well as warehousing. And I've even seen literally this week, one of my customers just posted a blog post about how they're doing data science against Snowflake. And we're seeing a lot more growth in that area. To Sarah's point, that stack is growing. Snowflake Ventures just this week announced that we are investing in Data IQ. A month or so ago, we invested in Data Robot. We've invested now in ThoughtSpot, which is doing augmented search. Very much along the lines of what Raul was just talking about with Data Station. And that's why Data Station was so exciting to me when I got to talk to Raul a couple of months ago about what they're doing, this idea of having the data centralized and curated and in one place, and trying to have a place where you can take care of the privacy, take care of the compliance, all in one central place. And to me now, it is about the data. It's not about what we call it, whether it's a data lake or a data warehouse or a feature set, whatever the terminology is, to me, that's starting to go away, right? As we've evolved with the technologies over the last decade, we can do a lot more today than we could ever have done before in the old technologies. And that's opening up a world of possibilities. I think Raul said in this last session, wherever data is shared, innovation ensues. And I'm absolutely seeing that. And it's very exciting to see. And I think not to be too many puns, the sky's the limit, right? With what we're doing these days. And so it's very exciting to see this, because again, it's been a long career, and now I'm starting to see the concepts that I'll say the thought leaders of our industry talked about 30 years ago are really now coming to fruition with all those possibilities.
Yeah, that's great. I'll just say that I think, Kent, you and I started in this business around the same time, and it's so nice to not have to. I used to teach an introduction databases course where the first thing I would do is I'd tell people, computers are not only just for computation, you can store data with them. And now you don't have to do that. Right now, there's everyone's so excited about data and all the things you can do with it. So yeah, great. Okay, and then our third panelist is Shant Hovsepian from Databricks. He's currently an engineer at Databricks working on the Delta Lakes product. And if you read, he actually has one of the more entertaining LinkedIn pages around, which is a hard thing to make entertaining. But he was a principal engineer at Cloudera earlier on, and he was also a founder of the world's coolest startup. I don't know if that was his opinion or if that was actually an official title, but the world's coolest startup, Arcadia Data, which was acquired by Cloudera. So Shant, if you can.
Yeah, thanks, Mike. Thanks. Thanks, Mike. Sorry. And thanks to the Center for Data and Computing at University of Chicago for inviting us and having this panel, and Sanjay and everyone for organizing it. These events are always great. I remember in grad school, these were always, it wasn't just the free cookies and food, but the fact that people are still showing up to this besides the free cookies and food is really exciting. But yeah, my background was like computer nerd. Clearly, I kind of got into computers late, but studied computer science in college and grad school, did systems research and systems work, mostly because I was like an open source nerd and just like the Linux kernel a lot. And then that eventually led to getting into the data space because, and Mike, you sort of indirectly know this, but as a systems person or researcher, it just turns out that databases like ML are now the ultimate use case for any large high performance or distributed system. We're not building better storage systems or operating systems for desktop use cases like we used to, where we're sort of running these big, powerful use cases. So while I was never really formally educated in databases, I did a database startup right out of school, which was this company called Astrodata, which was right around the time Google's kind of MapReduce work had come out. And so we were all about doing in database analytics. So scale out MPP distributed systems with an ability to actually, it's sort of like polymorphic UDFs in the SQL standards today, but simplifying the experience to go in and out of data science and computing. And that was acquired by Teradata. So I spent some time at Teradata, which practically invented the analytics and data warehousing space in some sense. And that was a sort of a interesting and great experience to see the scale of that kind of a business. And being involved in that and kind of living in New York City, where, gosh, I think 80% maybe of their US revenue came from the 2-mile square radius in Manhattan. A lot of large enterprises is sort of the inspiration of this trend that we're sort of talking about now, where data is democratized, you have the data lake platforms, but essentially the economies of scale for data have changed completely. And we saw a whole need for net new applications that can leverage this new architecture. I think at the time it was tons of MicroStrategy and Teradata as what analytics meant. And as data became cheaper and more effective to store, the things you could do with it was more interesting. So set out to build this company, raised over $20 million to do essentially, data lake native visualization BI analytics and unlock that next wave of applications. Got acquired by Cloudera, worked on integrating that there, and then recently joined Databricks because I think kind of the problem in the data space that we've all been trying to solve, or at least I've been trying to solve since I started, was having a multi-paradigm execution environment, being able to do something like run Python machine learning code and run data engineering code and run SQL or streaming or procedural Java code that isn't PL SQL really well. And Spark is the environment and is the platform that's completely open, not just from a technology standpoint, but also how you can express yourself. And I think that was kind of the most exciting open problem in the data space. So joined, and it's been a lot of fun since then.
Great. All right. Well, thanks to the three of you. So, I heard some commonality in there. Obviously a lot of excitement about data just in general, but, this notion that there's this kind of convergence of use cases and modalities of working with data that are, used to be considered separate or used to be done by different companies, or used to be, handled by different parts of an organization that are all sort of now starting to come together. So I kind of want to pull on that thread a little bit. Before I go on, I just want to mention, because I forgot to do it during the introduction, if you have questions, and I hope to the audience, if you have questions, and I hope you do, please put them in the chat or the Q&A, and we've got a few people who are watching those, and will poke us if some questions show up that we need to address. So please send us your questions. So I guess I'd like to start off with some free consulting, I guess, from you guys. And I'll say, so, I mentioned I'm starting a data science initiative, or working with a bunch of people to start a data science initiative here at Chicago. One question I get from people when I talk about that is they say, well, I understand data science, people are excited about it, but like, what is data science good for? Like, what can you use data science for? And, I mean, to me, the answer is, well, what do you want to do, right? Like, anywhere there's data, data science is going to help you make decisions, but and get answers. But I guess what I'd like to do, since you guys spend more time in the real world than me, is I'd like to ask you to tell me sort of your favorite, your data use case, and what is the thing that you've seen out in the world where data has actually transformed the way that, some people got to do what they're doing, or a company or society or whatever, you find to be most transformative. Does anyone have any kind of pet use cases that they like to talk about?
I can definitely talk a little bit about like a pet use case, but what I'd also note too is that I think we're starting to see almost a transformation in thinking from like, I've got a bunch of data, what can I do with it, to rather like, I have a bunch of business problems. How can I apply my data and or other technical strategies and or other resources to solve those problems? And I think like that framing is very indicative of the maturity that we see in the data field. The other thing that I'd add as well is that I see almost kind of like a forking in the data world of data that is used to drive decision making, as well as data that is used to build products. So you see kind of the rise of things like ML-driven search and recommendation engines, or fraud detection systems. Like, that's engineering. It's building software with data. But then you also see things like product analytics or financial modeling, where you're really just driving business decisions with data. Somewhere in the middle is like my pet use case, perhaps. Like, I think experimentation is one of the most powerful applications of data science that I've seen in the past 5 years. I've been thinking about this, like, why has experimentation emerged as such an ROI positive use case for data, and one that really gets executive buy-in? The like simple and dumb answer is that like data scientists are scientists, so they should run experiments maybe. But frankly, I think like everybody kind of understands the scientific process. They understand, what a hypothesis is, how you design an experiment to test that hypothesis, how you generate results, and then how you act on those results. And because the scientific process is well understood, I think the path from data to decision-making becomes more clearly understood. So when I hear executives talk about experimentation, they're often saying things like, we increased experiment velocity by 30% and drove revenue by 50%, which is like something really amazing to hear as a former data scientist, that like execs believe data science is driving revenue.
Yeah, it's interesting. If you got a chance to hear the panel that was earlier this morning with Martin Casado and Nick Feimster, that was one of the points that Martin was making, was that he was saying that data science is and analytic, data science is more akin to science. You're really trying to discover, truths about the world in a much different way than sort of just in the past, where it was more, generating, KPIs and dashboards and things like that. Like, you're really trying to understand fundamental things that are going on out there. Anyway, it's interesting. I think, Kent, were you going to talk about?
Yeah, I mean, it's all, to me, it's coming down to what's the business problem we need to solve. What's going to be the most value for the business?
Mm-hmm.
And it may not be just having a dashboard anymore with a bunch of KPIs, right? It's, how do we go forward? How do we deliver better service to our customers? And I've got two use cases that from our customers that I think are fascinating, that both use data science and machine learning. And one is, one that I kind of briefly mentioned earlier in my intro. They're over in the Netherlands, and they are a grocery delivery service. And as you can imagine, with the pandemic, their demand just went obviously completely through the roof. And what they're doing with data science on their data is trying to improve the delivery times so that their customers are getting their vegetables when they're still fresh, right? And how to optimize that, optimizing their inventory, optimizing the delivery routes, and where it's coming from. And I have a phrase that I like to say, what we're all about now is, in the democratization, as Shant mentioned, is getting the right data to the right people at the right time. And I look at these guys, we're trying to get the right vegetables to the right customers just in time for dinner.
Yeah.
Right. And we have another customer that's a delivery service. Same thing. This last year has been crazy for them, because in one of their big cities is London, and London has been shut down a lot over the last year. And so their service has been in high demand. And so they've built an engine that is, just like all of the others, DoorDash and everybody are doing this. You've got multiple locations where the food might come from. So I order from my favorite pizza brand, right? Well, there might be 5 of those shops in the city. So they're working on taking the GIS data, traffic data, as well as inventory information and things like that, and trying to real time generate where should Kent's Pizza come from, which store, which of the 5 stores. It might not be the one that's closest to him, because there's a traffic jam between the one that's closest to him and his house. And so they're actually real time then feeding routes to the delivery drivers so they get the best route to the customer, but also picking which shop they're actually going to get it from. So obviously they got to take the order. We've got to be able to go out and look and see, of the 5 shops that are out there, which one can actually fulfill the order, and which one will get, if we pick it up from that one, which one will get to the customer fastest. So again, delivering the hottest pizza to our customers in the shortest time possible in time for the game, whatever it is. And those are applications that, 20 years ago, I never would have envisioned, right? In the I'll say the traditional data warehousing world, that wasn't something we were looking at. We were looking at how many pizzas did we sell last month, and which campaign brought us the most revenue. And so we were able to look at it in arrears, but now we're looking at, forward forecasting, but in something like this, it's real time to provide better customer service and a better experience for the customers today. And it's all through using data science and the power of the platforms that we now have today.
Yep, that's great. So I detected two themes in your answers. One is food. So clearly we see what your priorities are.
I'm Italian.
And the second is this notion that when we used to think about records sitting in a database, and we think about, I love this thing about the right data to the right people at the right time. What that data is representing are things in the real world, and so there seems to be, because of real-time processing and the ability to grab data from lots of places, there's now an ability to sort of more tightly couple the data that we're working with to what's really going on in the world. And so there's this interesting connection to the physical environment that, I think is coming out in a lot of applications.
Yeah, you just reminded me, and it's might because every time I look out my window now, I see construction, but the use cases that really always resonate with me are when you got the sort of extraordinary technology mixed with the ordinary kind of boring day to day. And business value is an important one, but like construction companies, sort of this industry that really hasn't seen a major change in business value. You think of hard hats and hammers, but 1% gain in improvements for projects that are like always delayed is usually a huge deal. And we had a great customer, Bechtel, who actually not just basic data science and analytics, but like use deep learning to mine all their project plans and schedules, and essentially like use that information to come up with the optimum schedule for recommending construction sequencing. They got like a 10% increase in savings, which was sort of unheard of in that industry. But it's one of those things where you think of a foreman in a room looking at a stained calendar, trying to figure out the best plan. And now deep learning is sort of part of that conversation. It's just very exciting to see where the world's going to go by integrating like true AI and machine learning into the sort of most ordinary day-to-day activities.
Mm-hmm. Yeah, and that brings up, I had heard at a conference actually in Amsterdam a couple of years ago along the machine learning and data science thing, is like having more data available is more important than refining even the model itself. That, having more and quality data and gives us better results. And that's a great example that you just gave, because what we're able to do today, the scale that we can do it at today, what we originally called big data, right, is we've reached that point now. Not only do we have the big data, but we've got the big compute to go with it, so that we can actually get more out of that data and take advantage of that scale, which was something, again, when I started, a 10 gig data warehouse was monster, right? That was a monster size. And, 100 gigs was a VLDB, right? And now we're up to hundreds of terabytes and petabytes of data, and working our ways up to people with tens and eventually be hundreds of petabytes, right? The scale has just changed so dramatically. And being able to get all that data in one place is making a huge difference.
Yeah, I think it was like a well-researched like academic finding, right? Like that essentially, we can only tweak and refine our ML algorithms only so much. And it's about like data accessibility, which I think also goes to show the importance of open data, like having open accessible data platforms where it's less about the specific implementation or which algorithm you're using, but having the availability and openness of all of the data sets to power those algorithms is kind of probably the next interesting frontier in some sense. Like the AI will only be as good as the data we feed into it.
Yeah, great. Well, hold that thought, because I want to go there next. But Sarah, why don't you?
Yeah. I mean, I think the thing that I was going to mention as well that is potentially interesting from a research perspective is that kind of the combination of data practitioners in industry trying to represent their data sets in a way that mimics their business and the real world, as well as this emphasis on the kind of importance of data at scale and having a lot of data. It is also making people, I think, reevaluate how they structure and represent data. So in the past, I'd say that like a lot of companies were trying to figure out like, how do I represent my data in tables or data frames? And some of the conversations that I'm having nowadays, and it's really exciting because it's just starting to happen, is like, if I'm a trucking brokerage and I understand kind of the relationship between the market participants on the supply side and the demand side, how do I best represent those entities and the relations between them, which may be causal in some cases as well? Or like, if I have all of this data and I know I'm going to be building ML models with it, but I probably don't have all of the resources kind of available for feature engineering. Like, how do I represent this data as embeddings so that I can support a wide variety of use cases? So there's a lot of stuff going on too, and just thinking about like, what are the right data structures and representations to support the business, not just to kind of like fit the business to the structure.
Yeah, it's interesting. I've been teaching the introduction to data science class which is a mixture of, statistics and computing and as you'd expect. But one of the things I think that's most surprising to students, I mean, they understand, a bit about coding, and they understand a bit about, statistical, they know what means are and things like that. But the thing that kind of blows their mind is the idea of a data model, and the thought that you can have a language for describing data in the abstract is just not a natural thought to people who haven't spent a bunch of time thinking about databases. So,
I've spent a lot of time explaining data models in the last couple of decades. And one of the things that I found, and particularly in the data science area, is like knowledge graphs. And the graph paradigm seems to work really well. I'm an expert in this approach called Data Vault that Dan Lindstedt invented. And the grocery company that I just mentioned, they literally put the blog post up. I saw it yesterday. They're using a Data Vault model underneath and using that to drive the data science. And I found out with, talking through some graph database people a while back, about 2 years ago, realized that the Data Vault approach is like a relational representation of graph. And if you start looking at the model and you talk to data scientists like it's a graph model, then they find they can follow the relationships. They go, oh, okay, well, that's really a node, and that's a vertice, and these are properties. And then all of a sudden the model made sense. And so in some cases, what I'm finding is it's, like you said, there's no familiarity with this concept of data modeling that we've been doing in the database world for, back to Chen, right? And we just find different terms to explain it to people. And don't talk about third normal form. Right. Don't talk about dimensional models and say that's a fact and that's a dimension. No, okay, these are business entities. Let's use business terms. And this diagram is just showing you the relationship between a customer and their nearest store. Yeah. And a patient and the physician and the clinic and the treatment, whatever it is, and explaining it that way and not getting hung up on I'll say the diagramming technique and, what does it actually look like in the platform? That's kind of irrelevant. And I think, again, Raul's presentation just now about Data Station talks about that, about abstracting that out. So you ask the question, business person should be able to ask a question and not have to understand the structure of the data to get the answer. Right?
Yeah, absolutely. So great. So I want to jump back. So Shant started talking about the power of bringing data together, and I think that showed up in both of Ken's and Sarah's examples as well. So let's talk about data sharing and what are you guys seeing in the data? What's easy about data sharing? What's hard about data sharing? What needs to happen for this vision of kind of whether it's open data like Shant was talking about, or a marketplace of data like, Snowflake and other companies have been talking about, like what has to happen to make data sharing really work?
It's got to be governed. You got to have the governance, you got to have the controls so that you can protect the private data. You can meet the compliance requirements. That, of course, comes up with our European customers all the time, talking about GDPR. And now we have CCPA in California. And yeah, the technology is growing, right? And we obviously, you referenced Snowflake's data marketplace, but our whole data cloud, network is a, global data mesh to be able to connect all this data without having to copy it, which I love that. And Raul's talk about that as well inside of Data Station is like, let's not keep copying the data over and over again, because the more times you copy the data, the more risk there is of you losing control of it, not knowing where it is, of it getting inadvertently exposed or hacked. If you can keep it, if we can centralize it and apply the policies and controls to it in one place, but then share it and make it available in what previously we would have called a read-only database. Things like right to be forgotten become a lot easier, right? If you've got it once and you've shared it through this network of sharing, almost a virtualization concept, really, then if somebody says, well, you need to delete my data, you only have to delete it in one place. And then everybody who's been looking at that data set, it just disappears. It's gone, right? You don't have to go chase it down to find it out. but we're seeing just, huge applications of that. Our founder, Benoit, started calling it the World Wide Web of data. And I think that's a great visual in my mind for seeing how this data sharing works and building a network. And again, I'm really stuck on Raul's comment from before: wherever data is shared, innovation ensues, because it really is just giving so much more opportunity for people to do different kinds of analytics, apply different machine learning and data science algorithms to data they might otherwise not have had, for organizations that can't afford to go collect the data themselves, but somebody else has already collected it. If they could just really easily share it with them, well, then they can take that next step to what they're trying to accomplish.
Yeah. So I want to go back to a term that Shant used, is open data, because in some sense, open data sounds to be almost the opposite of what you just said in terms of governance and compliance. So I don't know, Shant, do you have any, when you say open data, how do you envision open data working?
Yeah, I mean, it's sort of nebulous, but I think like open is sort of a very important part of enabling sharing and growing. Like, if you think historically, like some of the greatest revolutions recently in humanity, like railroads, like sort of enabled commerce, and that had to be an open standard. We had to define some things and open up the way these were built and connected. Kent mentioned the World Wide Web. Actually, when Tim Berners-Lee started all of that stuff, the most interesting thing is like HTTP is an open protocol. It was out there, it wasn't proprietary. Like, I don't know if e-commerce would have taken off and become what it is today if the fact that you couldn't just look at every HTML page and see the code that made up for it. If it was a world of proprietary jars, I don't know if we'd have the same kind of innovation. So I think there is data sharing, and access to data is really going to unlock probably the next revolution. But a lot of the core part of it, and industries have been saying this for so long, like Oracles of the world, like, just give us all your data, trust us, we'll put it all in one place, everything will be great. But that's sort of been a hindrance, I think, to innovation and openness, and sort of letting the owners of their data actually have that control, I think is going to unlock some stuff. And I mean, I know Sarah personally. So Sarah, you were at Palantir, not straight under the bus. Like, that's a great example of a wonderful company that had all of this data, and like, it was super valuable, but who owned the data, or that sort of became a problem at some point later on. Like, you probably have a lot of thoughts. You've been in this space too for a long time.
Yeah. So it's interesting, because I think there's some things to discuss in terms of like what technical adaptations need to happen to enable data sharing, which is probably something related to the open file formats and governance and things of that nature. Frankly, though, when I think about like the biggest hindrance to data sharing today, I think it's more of like a socioeconomic problem. So like for the past, I'd say maybe decade or so, companies have been like convinced that like data is the new oil. Treat data like an asset. And that actually leads to this much more kind of like protective mentality, where companies might talk about data sharing, but really I don't see them kind of moving in that direction. I think data sharing internally is powering a lot of innovation, but until we can really demonstrate the ROI of data sharing externally, there's still going to be kind of much more of an incentive to like hoard data, if you will. Then the other kind of problem that I see with open data sets too. So interestingly, at Palantir, one of the deployments that I worked on was with the Department of Sanitation and Housing, the mayor's office of data analytics in New York City. New York City had a big open data initiative. And when you look at open data across like various municipalities, like, pardon my French, but like, it's crap. And it's crap because like nobody has an incentive to really deal with like some of the data quality issues or to like own that governance process. And so like a lot of the data that has become open is frankly like not even usable. So you've got organizations that are hoarding their data. You have open data sets that are like of abysmal quality. And I don't think that those are technical problems.
The data about crap was crap. So yeah, that's meta crap.
Oh, geez.
Well, Jim Gray famously said, he started working with astronomers, and somebody asked him, why is he spending all this time with astronomers? He said, oh, I love working with astronomers because their data is worthless. And, that meant that they could just send it all over the place and share it.
Didn't have to worry about it. Yeah. We see a lot more companies though that are sharing data with partners now. And even like, Goldman Sachs is using data from FactSet to help drive some of their portfolio management. And that's where I think some of the incentive is, Sarah, is in the ability to monetize. If they can monetize some of this data with partners, and you think about Nielsen, who's been sharing data for 1,000 years. Well, now they're able to do it more directly, but they have now an incentive to make sure that data isn't crap. Right? Because somebody's paying you for it. And there's new companies now who had data that they never thought of sharing before, but then find out from working with some of their business partners that, well, actually that data has value to their partner. And now through a data sharing mechanism, being able to make that accessible to them in near real time, well, that provides a bidirectional value. And so there is, on the data provider side now, the incentive to make sure that it has good quality data. Because, if you want to be a data provider, you don't want people writing the data equivalent of a bad Yelp review for your data, right?
Exactly.
So I think that's changing. I think we're starting to change that. This whole idea of the data economy is growing, right? And it's there's starting to be some new innovative business models around that. On the governmental front, we saw that with the state of California using the COVID data set that another one of our partners put together and made it available for free. Well, then the state of California was able to leverage that along with their own COVID data to make data available to the people of California on their website. And so you've got, I'll say, the data for good side, right? And helping out the general public, but also then the monetization side from a business perspective, that both of those are starting to emerge even more so. Again, because of the technologies that are available. Some of them are making the data available for free. So does that meet your definition of open data? If it's available for free, that you don't necessarily have to pay for it. Sorry, that's my dog is whining to escape the office at the moment. And she always does this. She makes it about
Just let her out, the poor thing.
But I can't let her rampage the house alone. So she's like a small toddler, right? But anyway, I think it's changing. I think that is starting to change now.
Cool. So I just want to mention to the audience. So I've been asking a lot of questions, and I have a lot more. But this is an opportunity for you. We have representatives from probably the two hottest startups, or I don't know if Snowflake calls themselves a startup anymore, in the data space in the past couple of years, and we have the person who's funding the next one. So it's a great opportunity for you to ask about what's going on out in the data world and what's happening in the future. So please start sending in some questions. I guess one thing we haven't talked too much about so far is AI and machine learning. And, we talked, obviously data, is kind of, what lies at the root of intelligent systems. But I'm sort of curious about the other question, which is, how can AI and machine learning help data management? So what are you guys seeing in interesting things in data people eating their own dog food and using analytics to run their systems? Are you guys seeing anything interesting there?
Well, I'd see it inside of Snowflake. We do run our IT department. We've had a couple of blog posts recently. Our CIO has been doing some about, we say drinking our own champagne instead of eating dog food. But
Yeah, I
yeah,
didn't want
I get, you said you and I have been around for a while, and that's what we all used to say is eating your own dog food. But we're
A hungry
able
dog
to,
in the room. It's
yes, and I had to have a hungry dog in the room at the same time. Yeah, the being able to mine that data, even the metadata around our service, right, and the customers that we're supporting, in order to make better decisions on our product development, and how we support our customers, what features are being used, all of that sort of thing. And so that's, again, having that, we have a data science team inside of Snowflake, right, and that's what they do. Right. We use it in the, for marketing analytics. That's obviously, that's a big one, but also on the customer support service side. All of those things are there. Is how do we better support our customers by applying these approaches to the data that we actually have in front of us.
Mhm.
So, I mean, one thing that I'd note is that like there's a lot of opportunity there. You see things like, learned indices and essentially like learned DBMS, like fully learned DBMS systems and things like that. And I think like there's so much that can be done, but like machine learning and AI, like it is still really, really hard. And it's hard for many of the reasons we discussed. It's hard because it's hard to build those really comprehensive data sets and manage those data sets and access those data sets and govern those data sets. I think there's also just a widening gap between research and industry, in that like a lot of the research focuses on unstructured data, yet like what people are using in industry and what they might need to build these sort of learned systems are really structured data sets. So actually, I think there was a really cool effort. I think it may have been a collaboration with Databricks and Intel. I can't remember the name of the benchmark. I'm happy to send it around, maybe like ExoMark or something like that. But essentially, it's a benchmark data set that includes, logs, metrics, and events from like a bunch of Spark jobs. And like that's actually the sort of data set that I think we need in industry, or rather to bridge this gap between industry and academia. They had kind of like perturbed the jobs with chaos engineering approaches. If we're going to build learned systems, like you can't build something learned from first principles per se. So, having access to the data sets that companies like Snowflake and companies like Databricks are using, I think is absolutely key.
Yeah, thanks for saying that. As a researcher, not in one of those companies, that's our biggest bottleneck, is getting a good understanding of real workloads. And real data is actually not so hard to come by, but actually understanding what people are trying to do with the data and what their requirements are and what the patterns are is really, if anyone wants to make that kind of data available, I'm sure the community would love it. Shant, are you a fan of?
Yeah, it's simple. I think like Mark Andreessen at some point, right? He said software is eating the world. And I think it's fair to say now AI is eating software. Like we will find AI.
I went to an AI company and gave a presentation to a bunch of the engineers, and I basically said that I was like, if you guys are successful, you're going to put yourselves out of a job, and they were very unhappy with me. But I said, I was like, why not? You can automate anything. Why not automate coding, right?
There's always bugs to fix.
And I think that's just a matter of time, because there's code generation software out there. We used to call them case tools, right? Yeah. So at what point does the AI be able to look at, I'll say the basics of the system and figure out what code needs to be generated without a human having to say, declaratively, here's what I'm trying to do, that it can go look at a raw data set. And people can do this now, I know already, profile that data and figure out how it should be connected, and then build an interface for somebody to access it. And we're probably not that far away from that.
Yep.
Yeah,
So we got our first question from the audience. Did somebody have something they were going to add? So the first question I got in from the audience is a question about diminishing returns. This actually came up in the fireside chat earlier, where there are a lot of problems where as you improve your model or as you get more data, you hit diminishing returns where the accuracy of your model increases only a little bit for some huge extra effort. And so the question is, have you seen problems where that happens, where getting more data either doesn't help or in some cases even makes things worse? Or is it always the case that more data is just better?
Yeah, I mean, it's definitely the case where like taking out a feature can actually improve your model performance more than adding a new feature. I think I've seen that both as a practitioner and now in discussions with like former colleagues, et cetera. I think one of the things that's interesting that we haven't discussed is kind of the computational inefficiency and memory inefficiency of machine learning and AI, and what this is driving in companies like Uber and Pinterest, et cetera. It is really initiatives to actually understand what data sets are going to kind of lead to the biggest increases in performance. So what their focus is on now is actually like removing features that are either going to cause kind of instability with regards to prediction accuracy, or that just have a minimal impact on the model performance in general. So it's not just about like throwing more data, it's about throwing the right data at a model.
Mm-hmm.
Yeah, and I think that's one of the challenges and this is, you mentioned the data swamp, I think earlier, right at the very beginning, is that was one of the challenges at early attempts to implement data lakes, is people got crazy about, well, we're just going to store all the data for all time. And okay, why? Was there a benefit there? And so you can go overkill without really understanding the utility of the data that you're working with. And if you do it too fast, you start accumulating a lot of data too fast, then you can lose control of it fairly easily, because you now don't really know what you've got. And anybody who's trying to go in and find something, now it becomes very difficult for them to find. And that's where, I'll say what I'm seeing people do is they may be doing that and sort of doing a more traditional data lake approach, but adding another zone on top of that, where as they discover the value of the data, they move it into a more refined zone, right? And put that structure around it and put the security. Really, the lake has to be not as open, unfortunately, in some ways, because if you're talking about healthcare or finance, you can't let just anybody go look at it. But figuring out what's going to be the most useful data then is the challenge, right? When you've got this, onslaught of data available, it gives you lots of opportunities. But like you said, Sarah, you could go a little too far and find out, that's too much. It doesn't actually help us solve the problem. It's actually creating a different problem. And the challenge, of course, is finding where that diminishing returns happens. And I guess that's through experimentation. Like you said, a data scientist, it's iterate, fail, try again, go forward, go backward, and find out where the best fit is.
Yeah. I'm a big fan of that progressive cleaning, or whatever the right, we called it data spaces many years ago, but the idea of having different parts of the data lake that are at different levels of kind of organization and protection, so on. So we don't actually have much time left, and I've got a couple of questions that came in, but luckily they're both short questions. So I think what we should do, I'm going to ask both questions, and then we'll do a quick lightning round where each of you can pick one of them and answer it, or we can do a quick ask, do them both. But the two questions are, one is, what are the key technical gaps in current data lakes from your perspective? And then the other one, the alternative question is, what are some hardware trends that you're excited about? So gaps in data lakes currently, or hardware trends. So let's, we'll go in reverse order of how we introduced everybody. So Shant, you get to go first.
I'm going to cheat and do both. Just for data lakes, there's a wonderful CIDR paper from last year we published called Lake House, which sort of details why data lakes are swamps. It's some good academic reading worth looking at. But hardware trends, I think hardware drives the innovation of like the technology. You know, PCs made servers, gamers made like the GPU market, cell phones and ARM chips might change something else. I think one of the biggest underserved areas right now, we sort of touched on it, is deep learning. And there aren't enough high quality products and ways of doing it. Like even for the previous question, talking about data, I think, diminishing returns, it's about context. Like we've seen situations where having image and video actually is like a way of introducing more data, but a variation of data. And at least with Databricks and Delta and sort of our policies, you can have variety of data sets to get better quality. And we're seeing a lot more hardware technology for that, like Intel with bfloat and all the researchers. There's essentially, it feels like, I wasn't around then, but like maybe in the early 80s, it's just like all these chip companies coming out, building all these different types of chips before we standardized x86. Something similar is happening right now with neural processing units. And I think that is going to drive the future of the next kind of big wave, because it's always some, turns out we don't need as much precision in our floating point numbers, yay. And that is drastically going to change the way we build technology going forward. And that's kind of the most exciting thing for me, and some of the work we're actually doing at Databricks as well. So
Great.
Selfish.
Okay. All right, cool. Kent, you want to pick one? And
hardware, IoMT, Internet of Medical Things. So medical devices getting hooked up, whether directly into the network or on the edge, and just providing us real-time data on to help patients. And then now it really is a matter of life and death, and we can improve patient outcomes by being able to act on the data coming from those devices.
Very cool. And Sarah, we're going to give you the last word. So.
Well, I'll answer both, but I'll try to be as terse as possible. So on data lakes, I think like fundamentally the discussion about like data science and analytics or data warehouses or data lakes, like what it reduces down to is Python versus SQL. And we don't have great ways of supporting both yet. I know both Snowflake and Databricks are working on this, but I do think that like having a best-in-class experience for Python and SQL is an opportunity and a gap. On hardware, I'm a former data scientist and really like a former statistician, so I'm biased, but I think like the big opportunity or exciting thing is like making it disappear. So from like the machine learning perspective, for example, we're investors in a company called OctoML. They develop an automated machine learning, deep learning compiler stack so that as a model developer, I don't need to think about where my model is running or what the hardware backend is. And similarly, I think there's just so much room to grow in serverless. We're still thinking about servers. Nothing is serverless, so. Great.
Okay, there's another question in there that I think is a question, oh boy. Now I started, so I have to say it. So the question is, everyone's talking about sharing data and sharing, and the question is, how do you see Snowflake and Databricks complementing each other in this sharing economy to help their customers more? That is obviously from a customer. So I don't know. Maybe I'll let you guys off the hook, and you don't have to answer that one.
And say, well, we have had joint customers for years, and we have a optimized Spark connector, and so people have been able to run Databricks jobs against data in Snowflake for at least 3 years, if not longer. I can't remember when that one originally came out. So we have worked together. I'm not sure. I think the rest of it's above my pay grade.
Yeah. No, I think the compute's easy to work together, but it's all about data. And remember to like I think with Snowflake, the data is always in Snowflake's control, but they recently added a lot of great support for external tables. So now you can have data in S3 in an open format and Snowflake can read it. And that means that you can get that exact same great experience from Databricks. And then Snowflake can also have access to data without ever having to actually move tons of it, right? Because now the data is back to your control and yours. And Snowflake they have a great external open data format connector support recently released. And that's sort of always been the way of doing things in Databricks. And yeah, there is a good Spark Snowflake bridge connector thing to use as well.
Right. All right. Well, I see Sanjay's here, so I think that means he's going to tell us
off.
We're out of time. But I just want to thank the panelists. It was great. It was really a privilege to have you guys spend some time with us and give us your insights. You guys are at the cutting edge of what's going on, and really appreciated the conversation and the insight. So thanks very much.
Just standing on your shoulders, Mike. You guys did all the real work.
Yeah.
Yeah, thanks for having us on again.
Thanks, Sanjay.